Welcome to fourth quarter. We are starting the quarter with a new unit called Binomial Expansion. Basically what we're doing is we're taking a binomial, two terms, and we are raising it to an exponent. And hopefully you notice as we go through this unit, you're going to see some patterns emerge, and we're going to be exploring those through this unit. So let's get started with binomial expansion. And we're going to start by revisiting Pascal's triangle. We saw this when we looked at binomial probability, and once again it's going to show up in binomial expansion. So let's go ahead and redraw the first 5 rows of Pascal's triangle. If you remember, it starts with a 1 on top, and the next one is just a 1 and a 1, pretty simple. It always starts with the 1, and then to fill in missing terms, you can just take the 2 above it and add. So 1 plus 1 gives you a 2, and then it finishes with a 1. We have 1, 3, 3, 1. 1, 4, 6, 4, 1. Now you might think this is the 5th row. It's not. That was actually row 4. So we got to go one more. 1, 5, 10, 10, 5, 1. So as you're looking at Pascal's triangle, that top number 1 is technically row 0. So this is row 0. And then we get to row number 1. And then we have row number 2. We have row number 3. We have row number 4. And we have row number 5 is the last one that I had you look at. You can go further and further and further. Right now, I'm just going to have us, as far as doing it by hand, we'll go through row 5, and we won't go much further than that. I do want to point out one other thing. You can always get these numbers by using the combination button on your calculator. So we talked about those before. If you want this one here, you can get that by doing 5 choose 0, and that would give you a 1. Anything choose 0 is a 1. If you want this term here, you could do 5 choose 1. This next one would be 5 choose 2. This next one would be 5 choose 3. This next one is 5 choose 4. And the last one would be 5 choose 5. So if we get to problems where you don't want to have to memorize Pascal's triangle and look at all the rows, you can just type these into a calculator to get a specific number that you're looking for. So just a reminder about that. So that's a little bit about Pascal's triangle. Now, let's see how we can use it. Before the break, I had you expand x plus 1 to the 5th power. I actually made you go to the 6th power, but for now, we're staying with 5. And you had to multiply a whole bunch of polynomials, and it was a really tedious process. You probably didn't enjoy it very much. Now I'm going to show you the quick way, and this is a process called binomial expansion. So first, just a general format of what you're going to be doing for this. You're always going to start with your Pascal number. So this is going to be the number that you pull off of the triangle, or in some cases you might have to use a calculator. It's just going to be n, choose k. And then it's going to be multiplying the first term, and you're going to have the second term, and there's going to be some exponents that go on the first and the second term. So the first term, the second term will get raised to the k power, and the first term gets raised to the n minus k power. That might not make much sense to you right now, but when we start dealing with numbers, it'll probably make a little bit more sense. So just to recap, you're going to take your Pascal number, get it from the triangle. You're going to multiply it by the first term, which is raised to an exponent, and by the second term, which is raised to an exponent. Let's probably do an example. That might help you out a little bit more. So what we're going to do is we're going to expand x plus 1 to the 5th power. This is your first term, x. This is your second term, a 1. And we are going to be looking at row 5 on Pascal's triangle because it's to the 5th power. So what I like to do is I like to set up every single term first, and then I'll deal with multiplying and simplifying at the end. So we're going to start I'll go over here. We're going to start with row 5 of Pascal's triangle. That's 1, 5, 10, 10, 5, 1. And I'm going to start with the first Pascal number. That's a 1. Then I'm going to multiply it by the first term, which was an x. And I'm going to raise this to the lowest or the highest power possible, which in this case is a 5. Bless you, Maya. And then I'm going to take the second term, which is a 1, and I'm going to raise that to the lowest power possible, which is a 0. And later on, we'll multiply all these out. That will give us our first term. To get the next term, we take the next Pascal's number, which is 5. And we're going to take the first term, which was x, and instead of raising it to the 5th power, we're going to drop it down by 1. Raise it to the 4th. And we're going to take the second term 1, that's this 1 right here. That's going to get raised to the 1st power. Now we're going to be counting upwards. 0 is now increasing to a 1. And eventually, those will all get multiplied together. We're going to keep this pattern going. So the next Pascal number is 10. We're going to have x to the, we go 5, then 4, it goes down to a 3. And your next term is a 1. Goes to the 2nd power. You'll notice that these exponents always add up to 5. 5. And 5. So whatever the exponent is in the binomial expansion problem, that's what your exponents need to add up to there. We'll continue. We have 10. This x gets raised to the 2nd. This 1 gets raised to the 3rd. Your next Pascal number is a 5. X to the 1st and 1 to the 4th. And lastly, we have 1. X to the 0 times 1 to the 5th power. So now all we have to do is multiply these all out. So here's something nice. Anything to the power of 0 is 1. So that's a 1 times 1 is just 1. So all you're left with is x to the 5th power. And for the next one, we have 5 times x to the 4th times 1 to the 1st is just 1. So 5 times 1 is 5. And then we have x to the 4th. 1 squared is just 1. 1 times 10 is 10, so this becomes 10x to the 3rd. And you could probably do the rest of these pretty quickly. This becomes 10x squared. This becomes 5x to the 1st, and this is a 1, this is a 1, this is a 1, so it's 1 times 1 times 1, which is just 1. So these would be all of your terms in the binomial expansion. Your final answer, you should just write it out as a polynomial. So it would become x to the 5th plus 5x to the 4th plus 10x cubed plus 10x squared plus 5x plus 1. And that is the final expanded answer. We're going to do one more example using, again, binomial expansion. This time it's to the 4th power. Hopefully you remember the 4th row of Pascal's triangle is, you can just look up here, 1, 4, 6, 4, 1. So I'm going to make a note of that. 1, 4, 6, 4, 1. And what we're going to do is we're going to start with Pascal's number, that's 1. Then we're going to take the first term, which is a 2x, and we're going to raise that to the highest power possible. In this case, it will be a 4. Then we take the next term, negative 5, raise it to the lowest power possible, which is a 0. And then we're just going to go down, and we're going to use the next Pascal number, that's 4. And we're going to take the first term and raise it to the 3rd, and then negative 5 gets raised to the 1st power. Then we take the next Pascal number as a 6. We get 2x squared, and then negative 5 squared. We have 4 times 2x to the 1st times negative 5 to the 3rd. And lastly, that's to the 0 power, and that's to the 4th power. So hopefully you're noticing the pattern here. This is just your Pascal's row. 1, 4, 6, 4, 1. We're taking that first term, which is 2x, and it's getting raised to descending exponents. So we went 4, 3, 2, 1, 0. And here we are ascending. We're going up 0, 1, 2, 3, 4. So hopefully setting it up isn't so bad. Now what we're going to do is we're going to multiply these all out. So let's start with this first term. Anything to the power of 0 is 1. And 1 times 1 is 1. So now I have this 2x to the 4th power. What this really means is 2x times 2x times 2x times 2x. So the 2 times 2 times 2 times 2, that gives you 2, 4, 8, 16. So this becomes 16x to the 4th power. A lot of students look at 2x to the 4th power and they just think it's 2x to the 4th. But that 4 goes to the 2 and it also goes to the x. Next one we have is 4 times 2x cubed times negative 5 to the 1st. So let's start with this 2x cubed. So if I take 2x times 2x times 2x, that's going to be an 8x cubed. So this is actually going to be 4 times 8x cubed, and then negative 5 to the 1st power is a negative 5. So now what we have to do, once we've simplified those, is we just have to multiply them together. So 4 times 8, that gives you a 32. And then we multiply it by a negative 5. So this becomes a negative 160x cubed. Just a fair warning, you're going to get some really big numbers as we go through this process. So the bigger the exponents, the bigger your coefficients are going to be. On to the next one. We have 6 times 2x squared times negative 5 squared. Let's simplify this 2x squared first. So we're going to have 6 times 2 times 2 is 4. So this is going to be 4x squared. And then negative 5 squared means negative 5 times negative 5. That's a 25. To simplify it, we can take 6 times 4 is 24 and multiply it by 25, which gives us 600. So this would be 600x squared. Let's move on to the next one. It's going to be 4 times 2x to the 1st is just 2x. That wasn't a very good x. And negative 5 to the 3rd power is going to be negative 125. So we can take 4 times 2 is 8, multiply that by negative 125, and that gives us negative 1000. Don't forget the x at the end. And lastly, 1, 1. Those make it nice and easy. And we can take negative 5 to the 4th power, and that's just 625. So your final terms are here, and here, and here, and here, and here. And then we're going to write that all out as a polynomial. So we're going to get 16x to the 4th minus 160x cubed plus 600x squared minus 1000x, and then plus 625. There you go. I do want to point out one thing. Whenever you have a minus sign within your binomial, that's going to make your signs alternate. Positive, negative, positive, negative, positive. So that's a good way to kind of check and make sure that you've accounted for all those negative signs. So go ahead and try the next one on your own. I'm going to create a separate video for this last example. So go ahead and try the last one on your own. It's to the 3rd power, so you are going to use the 3rd row, which is 1, 3, 3, 1. Make sure you know how to set it up. Hopefully you got it right. And then come on back for that next video and I'll show you how to do the last one.